Hello guys, welcome to Nemtech channel. My name is Nehemiah and I'm very much happy to have you on board. This is lesson 5 on Scipy and we are going to talk about the graphs. But then before we begin, please take a minute, subscribe, like and share the video to your friends if you have not done so. And to the returning subscribers, thank you very much for your continuous support. Now guys, basically graphs are very essential data structure, and Scipy provides us with the module called scipy.sparse.cs graph, basically for working with graph data structure. Now let's talk about adjacency matrix. Adjacency matrix is a n(n) matrix where n is the number of the elements in a graph, and the values represent the connection between the elements. And perhaps let me show you how to find all the connected components with the connected underscore components method. So what we do before anything, first of all guys, I want us to import the Numpy module here, and also some modules from Scipy. So for Numpy we're gonna say import Numpy. Numpy is np should be s keyword np alias, and then we're gonna import also connected components from Scipy. So let me say from Scipy.sparse cs graph like that. CS graph import connected underscore components like this, I guess. And then again another module from Scipy. Let me say from Scipy .sparse we are gonna import CSI underscore matrix. Remember we talked about these steps in the previous lecture. Matrix. Then here we are gonna use the Numpy array here. So let me define this array with the variable n. Then let me assign it to np. Remember np is the alias for Numpy, np.array. And then here we are going to use a tuple for arrays, and then I'm going to use a two-dimensional array. So let me do this. Let me remember list defined using the squared brackets. Then the first list in this two-dimensional array, I'm going to use perhaps 0 0 1 2, and then the comma, and then the other list, array list, I'm going to say let me say perhaps 1 0 0, and then a comma, sorry, should be a comma, and then the other array list, let me say 2 0 0. Remember this is the last item, so we don't add the comma. Then let me now create a new array. Let me define it with the variable b. Let me give it b. Then let me pass it to let me say csr underscore matrix should be matrix. And then let me pass here a. Let me pass here that array a. And then to the print function, let me say print. Let me say print, and then underscore connected and basically connected underscore components. Underscore components should be components. And then we're gonna pass the new array here, which is we defined it with b. We said b. And then again, what I do in this case, we want to find all the connected components with this method connected underscore components. And so what I do, let me run the codes, and then again, basically this is how you can find all the connected components with this method here. So guys, let's talk about dict store. Now guys, basically we use the Dijkstra method to find the shortest path in a graph from one element to another, and it takes some arguments. The first one is the return underscore predecessors, and this one returns a boolean, true to return the whole path of the traversal, otherwise false. And then the other argument is the indices, and the index, basically this one is the index of the element to return all the paths from that element only. And then at the limit, this one is the max weight of the path. And guys, perhaps let me show you how to find the shortest path from element perhaps 1 to 2. And then here guys, we're going to use the Dijkstra. We are going to import the Dijkstra. So let me say, let me delete this one, and then let me say Dijkstra. Let me say Dijkstra, and then I think this is the spelling for Dijkstra. And then here, instead of components whatever, let me replace with Dijkstra, and then here we are gonna pass this the new array here. We're gonna pass the new array here. Also we are gonna pass what we are gonna use this argument return underscore predecessors, predecessors like this. Then we are gonna give it true. We're gonna give it true. Basically I say that true, the true basically return the whole path of the traversal, otherwise it is false. Then the other argument, let me use indices, and then this one I'm gonna give it 0. And remember I said the indices, this one is the index of the element to return all the paths from that element only. And then basically I want to return from 0. So what I do guys, let me run the code so that we can find the shortest path from element 1 to basically to 2. And then guys, basically this is how you can do it. This is how you can find that shortest path from element 1 to 2. So let's talk about something else called the Floyd-Warshall. Now guys, basically we use the Floyd-Warshall method to find the shortest path between all pairs of the elements. Like let me show you how to find the shortest path between all the pairs of the elements with this Floyd-Warshall method. Now here, instead of the Dijkstra, I'm gonna use basically I'm gonna use what I'm gonna use a Floyd underscore Warshall, like this. Let me just copy this one, then let me use it at the method there. Instead of Dijkstra, I'm gonna use the Floyd-Warshall, and then here we are gonna return we're gonna use these two arguments. Let me just remove these indices. Let me remove the indices argument. And then guys, basically I want us to find the shortest path between all pairs of the elements with this Floyd_Warshall method. And then again, basically this is how you can do it. This is how you can do that. Now let's talk about Bellman-Ford. Now the Bellman-Ford method can also find the shortest path between all the pairs of the element, but then this method can also handle the negative weight as well. What I do, let me, instead of Floyd-Warshall, let me replace with what? Let me replace with the this Bellman underscore Ford. Sorry, it should be Ford. And then let me just copy this here, and then let me use it as a method here, the print function. And then perhaps here let me also add another argument called indices, the indices argument. Indices, I'm gonna give it basically the starting point. Let me give it 0. Remember I said that these the indices, this one return all the paths from that element. Basically, if we say 0, it will return from from 0. So what I do is let me run the codes so that you may see the results at the terminal. And then guys, basically this is how you can find the shortest path from element basically from element 1 to 2, from element 1 to 2 with a negative weight. So guys, let's now talk about the depth first order. And the depth first order method returns a depth first traversal from a node, and this function takes the arguments. The first one is the graph, and then the second one, this is the starting element to traverse from graph from, that is the indices. Now so guys, perhaps here let me the values here, let me change and use perhaps let me use different values here, like perhaps let me say 0 1 0 1, basically 1, and then here perhaps let me use 1 sorry 1 1 1, and then this one let me say perhaps let me give it 2 1 1, and then perhaps 0, comma, and ensure that you have a comma because I want us to add here another array list. And then here perhaps let me say 0, and then let me say 1 0, and then 1, and then guys, here instead of Bellman Ford, I'm gonna use now the depth. I'm gonna use the depth underscore first, should be first underscore order. And then here the print, perhaps guys, let me just copy these codes. Let me copy this one, then I'm gonna use there the method, here the print function. Let me just use this one, let me paste it here, and then here guys, I'm gonna remove these other arguments, these ones. Let me just remove these arguments so that we may just pass what, the new array, basically the new array. And then I said that this one returns basically the graph, and also the starting element to traverse the graph from. And then in our case, let me begin to let me use 1. Basically, let me define the starting element to traverse the graph from. Let me give it 1. And then what I do is let me run the codes, and then guys, basically this is how you can traverse the graph depth first for this adjacency matrix. Now let's talk about the breadth first order. Now guys, for breadth first order method, it returns the breadth first traversal from a node, and this function takes the arguments the same as the the depth first order. So now in this case, instead of what breadth depth, I'm gonna use now the breadth. This is just the opposite. Let me say breadth should be breadth first order, and then also here let me use a breadth it should be not breadth, it should be D should have a a broad breadth. Also here it should be D breadth, the opposite of depth. And then now here what I do is let me run these codes. I guess the codes are okay, and then I guess basically this is how you can traverse the graph breadth first for this adjacency matrix. And basically guys, this is what I wanted to show you on Scipy graphs, and I think you've gained something. Please consider subscribing, like and share the video to your friends. Until next time, this is Nehemiah. Goodbye.